Welcome to the demo of the embedded system application midterm examination. First and foremost, we have to identify our rules and the ports which we are about to use. And the first one is door. We simply specify that the door is open. We agree on this, that the pin of the D port is set if the door is open. The same applies to ignition and lights. Ignition is on if the first pin of the D port is set, and lights are on if the second pin of the D port is set too. Then we agree on the fact that lights is on if it's 0 and it's off if it's 1. Further, we will see that it's crucial to identify this in order to analyze the whole system. Then we proceed to the truth table. We can see here door, ignition and lights, and the last column is for the condition. So we can see that if the ignition is off and lights are on, we get the general alarm. If the ignition is off and the lights are on, then we again get the general case, the general alarm. Well, the door is open, so we can see the pattern here. We can clearly identify that the pattern of having door open and ignition specifies us the serious alarm. And the very same thing is applicable to the general problem. We can see that if the ignition is off and the lights are on, it's general case. Let's move to the core process itself. We identify serious problem if, according to our DIL, it's 1-1 and then the wildcard. So the door is open, ignition is on, and it doesn't matter what lights are. All of that we output to the zeros pin of the port B. So we have to apply this type of filter, which is in complement results in FE in hexadecimal format. And the very same thing is about general one. So we get it's our door, ignition and lights, and that's PB1 pin, and that's our filter. If we complement it, then it's FD. So what do we do now? We apply XOR operation on the complements of our filter. After doing this, we specify the wildcard rule. So everything where we have star asterisk, we do OR operation on it. And lastly, we get all the ones. If all the ones are there, then we simply complement it and check the 0 flag. So by doing this, we can clearly see that the filter worked out and everything is fine. So the very same thing is about general one. Let's move straight to the code. We include the definition of ATMECA 128. We specify the org directory to start from the zeros line. So what do we do here? We set R16 to FF in order to make the port B output port, the emitter. And we set port D to zeros to make it as an input port available for reading. So then we jump straight to the branch main, where we produce the in operation on R16 from pin D. So we get all the pins of R16. Then we complement it. As I've already mentioned, if we consider this, if we agree that on is 0 and off is 1, we have to complement it to analyze according to our algorithm. What do we do next? We LDI R17, another register. We set the filter of the serious problem. Then we apply this filter by producing an operation of exclusive OR on R17 with R16 and store the result in R7. Then we OR immediate on O4, which is our wildcard rule, and then we complement R17. If everything is 1 and we complement it, then the 0 flag is set. So then we check if the 0 flag of the S register, then we jump to the series. What do we have in the series? We simply LDI R16 to the FE, we output this to the port B, and we jump to the main. So what does it do? It is simply a pattern of the light in the port B, the way it is connected. The very same thing is applied to the general case in order to identify the general problem. And lastly, we simply, if none of that happens, if none of the checks are successful, then we simply turn off all the lights and we output this to the port B. and restart the application again. So that's briefly about the way the code works, the assembly application itself in AtMega. Welcome to the second part of the embedded system application midterm assignment. And what we do here is we set the simul ID, we open the circuit, we set the circuit, and we can clearly see here the new circuit. What is different from the default one is that all of the buttons were substituted to the switches in order to make it a little bit easier to use it while testing. So let's load the firmware. We enter the application, debug, and the hex. We use it, and as soon as it's loaded, we launch it. So what do we see here? It's just our application. Here are D0 port, D1 port, and D2 port. D0 port is responsible for the door open or closed state, and D1 is for ignition, and D2 is set for our lights. So as we remember from the first part, we can clearly see that if we set the ignition at on and the door at open, we have this lamp here. It's the pin 0 on the B port, so we can see the lamp appearing here. We should filter out all of the other cases with the XOR. So if we tap some unrelated button, the lamp goes down, it turns off, and we cannot use it anymore. So what do we do if we set the lights on? It's the very same thing, as it is a wildcard. We are not considering this as a part of our case system. So we can turn it off and turn it on. It doesn't really matter. So let's check the other case, when the lights are on and the ignition is off. As soon as we have lights on and ignition off, we can see that the lamp at the port B at pin 1 is starting to light. It's our general case. And it doesn't matter whether we open the door or close it, it is still, the light is still on. The only thing which can affect this are some other ports. So we filter them out with the help of our XOR operator again, and our wildcard rule works just fine. So thank you very much for your attention. This is the end of the demo of the assignment, midterm assignment on embedded system and application. Thank you.